A very good morning to all. Today we'll be looking at how to calculate molarity and look at some shortcut methods so that it helps you to calculate molarity at ease. Many of the times we see students getting stressed and tensed when it comes to doing max problem or doing calculations. So after this lecture, I am very sure that you all will feel very confident to calculate molarity when it comes to your lab practicals or exams. So once you understand the basic concept behind all these equations, solving becomes very easy. You will feel happy and excited to do more and more calculation, and that is what we will be looking in the coming slides. Now, before going to the real concept of molarity, let us look at some basic examples, some real life examples to understand the concept of the concentration and to understand the concept of molarity better before looking at the equations. Now, let us take a big glass which can hold up to 1 liter of water, which is equal to 1000 ml of water. And if we add 1 cube of sugar into that, and if we consider that solution to be 1x, then if we take another glass with the same volume of water, and if we add 2 cubes, meaning you are adding double the amount of solute into that, then the concentration also becomes doubled, which is 2x. Now if we take a big glass with 2 liters of water, and to that if we add 2 cubes of sugar, then the concentration becomes 1x again. That concentration compared to the second glass, now this has become half because the amount of solvent or amount of water we have taken is doubled, so the concentration gets reduced. Now if we take another glass with 500 ml of water, and if we add 1 sugar cube into that, then again the concentration will be 2x, because compared to the first glass here, we have reduced the volume and added the same amount of solute, meaning the concentration in this glass will be higher compared to this, and since the volume is halved, the concentration gets doubled. Now, similarly to the similar amount of water, if we add 2 cubes, then the concentration again become double the amount of concentration in this glass, which is now 4x, because here with into the same volume of solvent we have added an extra cube of sugar, so the concentration also gets doubled. Now imagine the cube that we have added, the sugar cube that we have added is sucrose with molecular weight 342.3, and each cube weighed 342.3 gram. Now if you look at the first uh, glass that we have taken, so we are adding 342 gram of sucrose in 1 liter of solvent, which will give you 1 molar concentration. And similarly, with respect to each solute amount that we have added, the concentration also varies in terms of molarity. So molarity, as we can see here, is directly proportional to the weight taken, meaning if you add extra amount of solute, then there will be an increase in concentration of the solution given the concentration or the volume of the solvent that we are taking remains the same. So if you compare these two, we know the volume is same, but since the concentration increased, we are seeing an increase in the concentration. Now molarity is inversely proportional to the volume taken. So here we have added the same amount of solute or same number of cubes, but the volume in these two cases is different. So here we have halved or reduced the volume of solvent, meaning the concentration is doubled, so they are inversely proportional. Now let's see what is molarity. So molarity can be defined as the number of moles of solute per liter of solution, or molarity is number of moles per liter or number of moles per 1000 milliliter of solution. So moles of the solution is weight of the solute we have taken divided by its molecular weight. So molarity is weight in grams divided by the molecular weight into 1 by volume in liters, or weight in grams by molecular weight into 1000 divided by volume in ml. So most of the time when students are asked to do molarity problems, they always get confused whether it's weight by molecular weight or whether it's molecular weight by weight, whether it is 1000 by volume in ml or volume by 1000. All those confusion will arise. So if you start to analyze this formula properly and if you start to understand, such confusion does not occur. Now most of the time this is one area people get confused, and the result students get after doing the problem is either 1000 times the actual result, or 1000 times, meaning 1000 times can be either greater or lesser compared to how they put it in the formula. Now 1000 by volume. Now we have taken an example in the earlier slide where we have reduced the volume. So from 1 liter, which is 1000 ml, we have reduced the volume to 500. So in that case it will be 1000 by 500. So we'll multiply the answer by 2, which makes sense. So if the volume is reduced with other parameters remaining the same, the concentration should increase. So it ideally should be 1000 by the volume. So in another example, if we take 100 ml and dissolve the same solute compared to what we have dissolved in 1 liter, so what happens is we will get 1000 divided by 100, where you get a 10 in the numerator. So you will multiply whatever value you are getting here into 10. So you are getting a higher value for your molarity, which makes sense because you are dissolving the same solute in a lesser volume of solvent. Now we'll look at what will be the relation between molecular weight and molarity. We have already discussed how molarity is related to weight as well as volume. So it will be related directly to weight and inversely to volume. So what is its relation to molecular weight? Now consider we have a lot of compounds with different molecular weights, and if we plan to make a 1 molar solution in 1 liter of solvent, the amount of the compound that we have to take will be the same as its molecular weight. So for a compound with 75 as its molecular weight, we have to take 75 gram, dissolve it in 1 liter. It will give you 1 molar. Now consider we are taking the same amount and dissolving it in 1 liter, and look with respect to the molecular weight how the molarity is going to change. So imagine if you are taking 300 gram for a molecular weight compound of 300, then we will give or we will get 1 molar. And if you are taking a compound with 150 molecular weight, if you take 300 gram, its molarity is going to double. And likewise, if you are taking for 75, it again will increase. And if you are taking a compound having its molecular weight 600, then the molarity will decrease. So which means molarity and molecular weight, they are inversely proportional, and that is how the whole formula is formed. Now we know molarity is directly proportional to weight, it is inversely proportional to molecular weight as well as the volume. Now the other method to find whether the equation that you have written is right, you just have to know the unit of each of these parameters. So if you know molarity is moles per ml, weight is in gram, molecular weight is grams per mole, and volume in ml. Now if you cross these out, so gram and gram will go, so it will be mole on top, so mole by ml. So if you equate mole by ml on the left and right, it is the same. So if you try to swap these, like if the molecular weight is on top and weight comes below, you will never will be able to equate the equation. So that is why it is called equation, and that is how we can find whether we are going wrong in any part of the equation. Now let us try few examples. Now we know the units of each of these, and molarity is weight of the solute by molecular weight in the thousand by volume, and we have the idea that molarity is directly proportional to weight and inversely proportional to volume. So let's take a example. So calculate the amount required to make 1 liter of 1 molar solution of a compound A whose molecular weight is 150 grams per mole. So we cross multiply this equation so that weight stays on the right or left side. We take molecular weight on the other side. We will get weight of the solute is equal to molecular weight into molarity into volume in liters. Since it is in liter, we don't have to worry about the thousand. Otherwise, it will be volume in ml divided by 1000. So if you do that, we'll get 150 into 1, which is molarity, into volume in liter 1. So we have to take 150 gram and dissolve in 1 liter. So this is the usual way how we do the calculation. Now, knowing the concept of molarity, how it's related to weight and volume, we can find a shortcut. Now, by the basic molarity meaning, we can conclude that 150 gram in 1 liter will give you 1 molar, because we are now talking about a compound whose molecular weight is 150. So this will be the relation, and just by writing the relation, we know the amount that we have to take is 150 gram. Now we will be looking at a different problem with the same compound with same molecular weight, but here we are trying to make a solution of 1 micromolar in 1 liter. So this is the usual way that we will do. We will multiply molecular weight into molarity into volume to get the weight of the solute that is required. So molecular weight is 150, molarity is in 1 micromolar, so we have to convert that into the molar, which is 1 into 10 raised to minus 6, and then volume is in liter into 1. So this is where many goes wrong, meaning we might multiply 1 into 10 raised to 6, we might multiply 1 into 10 raised to 3, or we might not be doing anything at all, and we'll be getting the numerical value same like 150 or so, but then the units will all depend on how we tackle here. So in this case, the answer will be 150 into 10 raised to minus 6 gram, which is equal to 150 microgram. Now if you use the shortcut method, we know 150 gram in 1 liter will give you 1 molar. Now what we are going to find out is how much is required here. Now, since one for 1 molar, since we require 150 gram, if you are like going to find for 1 micromolar, what we have to do is just convert the gram into microgram, so you are getting the answer directly without any confusion. So this will actually help you to work with less error, and also if you are very much used to doing the conventional method, this can be actually used to make sure that our answer is wrong. We can just cross verify and find out the answer. Now with the same compound, we are trying to find out the weight required to find 2 millimolar. So the same equation, the same method will be followed. 150 into 2 into 10 raised to minus 3 will give you 300 into 10 raised to minus 3 gram, which is equal to 300 milligram. Now if you look at the shortcut method, this is the main concept. Now for 1 millimolar, you will be at 1 liter, you will be requiring 150 milligram. So for the corresponding decrease in molarity, since both these are directly proportional, when you decrease molarity, we have to decrease the amount of solute that goes in, and proportionally. So we take 150 milligram. But in our question, what we require is 2 millimolar. So you have to double the amount. So for 2 millimolar, you have to take 300 mg. So again, we are getting the same answer without much difficulty in calculation. And the main thing with this method is, like, once you get used to it, even without taking a sheet of paper or pen, you can do mind calculation quite well and get to the same answer. Now let's take another example. Here we are playing around with the volume. So calculate the amount required to make 1 ml of 2 molar solution of a compound with the same molecular weight. Conventional method, 150 into 2 into 1 by 1000, because we have to convert that into liters. So 2 is the molarity, 1 by 1000 is the volume in liter, and hence we will get 0.300 gram, which is equal to 300 milligram. Now if you look at the shortcut method, same again. So for 1 molar in 1 ml, so we are reducing the volume. So if you reduce the volume to have the concentration remaining the same, you have to reduce the solute that goes in, and it should be proportional. So when we decreased 1000 times the volume, we have to decrease the solute concentration also 1000 times. So 150 milligram in 1 ml give you 1 molar. Now the question is, we have to prepare 2 molar. So what we have to do for 2 molar, we have to double the amount, which is 300 mg, the same result without much of a trouble. The next question, calculate the molarity with the same molecular weight if 300 gram of it is dissolved in 100 ml. Now we are trying back to find the molarity. Now we know the weight that is added, the molecular weight, the volume, and we have to find the molarity. So it will be 300 gram divided by the molecular weight 150 into, since this is in 100 ml, it should be 1000 divided by 100, which will give you 20 molar. So here again, you should not be confused whether it is the volume in ml divided by 1000, or whether it is 1000 by 100 or 1000 by the volume that you are taking. And actually should, as we have already discussed, it should not be troubling you, since we know when you reduce the volume, the molarity has to increase. So to get the value above 1, it should be always 1000 divided by 100 rather than 100 divided by 1000. Now the shortcut method, same initial, 150 gram in 1 liter, which is 1000 ml, will give you 1 molar. So to get 2 or to get to have 300 gram dissolved, so you dissolve 300 gram in 1000 ml, it will give you 2 molar, because you are doubling the amount, you will get double the concentration. But the question is, what happens if you dissolve in 100 ml? So you are going to reduce the amount of solvent, which means when you reduce the amount of solvent but at the same 300 gram, the molarity should decrease, and decrease 10 times, because you are reducing 10 times the volume, the molarity will increase 10 times the volume. So you are getting the same answer. Now most of you will have the question, now we are dealing with like absolute values, where it is very easy to convert, like from 300 to 150 and so on, or 150 to 300. Now what happens if we have dissolved 200 grams, and how will you find the answer? So it won't be as straightforward as we see here. So the answer to that is like, find out for a value that is near to what is required. So in case here, if you need 200 to find out what is the molarity when you dissolve 200 grams, go with the same option, try to find out the answer for a value near to 200. Now in case of here, it is like 300 grams. So we know if you take 300 grams, you are getting 20 molar. So if you take 200 grams, which is more than half, we can predict the value to be between 10 molar and 20 molar. Now the easy way to find out is, you have to just cross multiply, find x. So x equal to 200 into 20 divided by 300, you will get 13.33. Again, the use with all this is like, you are not going to vary too much from your actual answer, and you won't be too much confused with whether your answer should be in the range of molar, millimolar, or micromolar. So once you practice this cross multiplication will help you to find out the answer for any of them. Now this is a problem that we have already discussed and we got the answer. Now you would have to understand that most of the, or in fact any weighing machine that we are used to cannot weigh 150 microgram. So if such situation comes where you have to prepare such solution, we need to follow some other techniques or some other methods to get to that, and that we will be discussing in one of my other videos that will be coming up shortly. So thanks for listening, and I hope this video was helpful, and wish that you practice the shortcut method and it will help to solve most of the molarity problems at ease. Thank you so much.